Project demo for SIT 210 Embedded Systems Development. The topic of my project is Automatic Dog Food Dispenser. My name is Ishan Vij, student ID 2190568662. Project purpose. The basic purpose of this prototype is to help dog owners to give food to their pets when required, to have surveillance on pets, to create an automatic dog food dispenser that can be controlled over internet using basic devices like mobile phones and laptops. Why build this system? To develop system that can detect pet when it's near its bowl, to detect when bowl is empty, to notify the dog may be hungry, to have surveillance on the pet, to develop a cost efficient solution. Design fundamentals. Design for security. This system has camera which live streams 24/7 and can only be accessed by the owner. And also all the data from the system is stored privately which can be used only by the user. Design for serviceability. This system is designed to provide service to pets as well as their owners. The prototype is easily repairable and most of the parts are cheap and it can be directly changed without any complication. Design for flexibility. Certain features of the system can be altered according to the user's demand, like the distance of the ultrasonic sensor from the pet's bowl. It can be changed as well as the code for it. Overview. To create a system that detects the motion of the dog when near its bowl, check whether the bowl is empty or not, send data and notification wirelessly to devices like laptop and mobile phones, operate food dispenser using mobile phones or laptops. Fundamental requirements: must be able to detect motion of the pet, must be able to check whether the bowl is empty, have the ability to live stream video of the bowl and the dog, receive notification when dog is detected and the bowl is empty, control food dispenser over the net. Functional requirements: the notification should be instant within seconds, the footage must be remotely accessible, the system must be able to work even when the distance between the ultrasonic sensor and the bowl is changed. Hardware required: Raspberry Pi, as most of the sensors are connected to Raspberry Pi. Argon particle, as it will operate the food dispenser. Ultrasonic sensor, it's connected to Raspberry Pi and it will check whether the bowl is empty or full. PIR sensor, it will basically check if the dog is nearby or not. Node camera, which will have surveillance on the pets. Male to male jumper wires to connect the sensors to the Raspberry Pi and breadboard. Male to female for the same reason. LEDs to notify the ultrasonic sensor is working and also as a replacement for food dispenser and resistor. Software required for this prototype: IFTTT, Raspbian installed into SD card, VNC viewer, push bullet, webhooks, ThinkSpeak, Particle Web IDE, Python script. Basically, whatever data is stored on webhooks will be transferred to Pushbullet using IFTTT and the notification will be on your devices. Let's have a look at the connections. Basically, there are two separate things here. One is Raspberry Pi, the other is Argon Particle. First, we'll have a look at the Argon Particle. The yellow wire connected from Argon Particle is VCC to the positive, while the red wire here is connecting ground to the negative. LED is connected to ground using the resistor, while the other end of the LED is connected to D5 using gray wire. Now we'll have a look at Raspberry Pi. It's a little bit more complicated here. It uses three sensors: the PIR motion sensor, ultrasonic sensor, and the camera module. LEDs placed there just to represent the ultrasonic sensor is working or not. Now the camera is directly attached to the camera module provided on the Raspberry Pi. PIR is connected to Raspberry Pi using the following connections. Ground of PIR is connected to pin 6 of Raspberry Pi. VCC of PIR is connected to pin 2 of Raspberry Pi. Signal of PIR is connected to pin 11, which is basically GPIO 17 of Raspberry Pi. Whereas the ultrasonic sensor VCC is connected to pin 2. Trig is connected to pin 12, which is GPIO 18. Echo is connected to pin 18, which is GPIO 24, while ground is connected to pin 6. For the LED, it's connected to ground of Raspberry Pi, which is pin 6, and the other end is connected to pin 3, which is GPIO 2. System architecture. Raspberry Pi is connected to PIR sensor and ultrasonic sensor and camera. Camera will just give live stream, so it's not represented here. Basically, it will give trigger the PIR sensor, which will detect if motion is there or not. If not, then it will loop back to the Raspberry Pi and it will go again. While if the motion is detected, it will trigger ultrasonic sensor. Ultrasonic sensor will further check if food's there or not. If not, then it will go back to PIR sensor. If yes, then using IFTTT from webhooks to pushbullet, it will send a notification to your device like a mobile, which will open a HTML link, which will trigger your oven, which will further trigger your food dispenser to dispense food or not. And before going back to Raspberry Pi, it will draw a graph on ThinkSpeak. Communication and notification between devices. Both of my devices, Raspberry Pi and Argon Particle, are connected over the internet. Raspberry Pi is connected to sensors, while Argon is connected to the dog food dispenser, which is represented using LED. Mobile phone is the connector between these devices. Python script will send a notification to mobile phone using IFTTT with the help of webhooks and pushbullet, using which basically a GUI or HTML page will open on your respective device, which will give commands to release food or not. In one of the case, the argon particle will dispense food, while in other it won't. And that's how they're gonna communicate. Let's have a look at my Python code. Import rpi.gpr as GPR, import time and import request. PIR is connected to GPR 17, trigger is connected to GPR 18, echo is connected to GPR 24, LED is connected to GPR 2. I have also made two variables here, current state 0, previous state 0. The code begins and it will print let's begin, and then while it will check GPR input of PIR, which is connected at GPR 17, and if 1, then it will set it to current state 0, and then it will again print ready. While true, current state will be gpr.input of PIR, and then it will set gpio.output for trig false, and then again trig 2, and then again trig false. If current state equals 1 and previous state is 0, then it will send a pulse, which will be the pulse start and check the time. And then again, it will check the pulse end and the time of it. The pulse duration will be the pulse end minus pulse start. And the distance will be pulse duration into 11150, which is a constant. The distance will be round off into 2. And it will say print motion detected, your dog is near the bowl. And if distance is greater than 10, then GPI output of LED will be high and it will print food is not there, and then R is equal to request.post is basically an IFTTT trigger, and then it will set previous state is equal to 1 and GPI.output will turn LED to low. Else, if the distance is less than 10 or whatever, then it will say food is already there and it will again trigger IFTTT but with a different text this time, and the GPR.LED will be low. And then it will change previous state is equal to 1, wait for 60 seconds, for which I put a delay of 60 seconds using time.sleep. Elif, if current state is equal to 0 and previous state is equal to 1, it will again go back and say ready, and then it will set previous state 0. Keyboard exception for quit, and then gpr.clear. This is the code for my camera. Basically, it will create a HTML page which will display 24/7 footage of my camera. It can be accessed easily by typing http colon slash slash IP address colon 8000. This is Particle IDE code. This is for my Argon. int pet food dispenser is connected at D5. That's basically my LED. And then I created a variable int times is equal to 1. And then set up pin mode food dispenser output particle dot function LED toggle. Digital write, I'll set pet food dispenser to low. And then for the GUI or HTML page, that's my buttons. If condition is command equals food dispenser on, then it will set pet food dispenser high. That's basically my LED. And then it will publish times, which is my variable, to the things peak, and then the food dispenser will go low, and then times will be increased one so that I can have a count of how many meals. Elif command is food dispenser off, then the food dispenser will go high low high low high low with a delay of 100 milliseconds to represent that the owner does not want to give food, else return -1. These are the two IFTTT I created. One is connecting webhooks to push bullet for motion detected. This is when motion detected and food is not there. This will push a link, which is our HTML link, so that user can decide whether to give food or not. While the other one is if motion is detected and food is already there in the bowl, so it will tell full bowl and there is no need to refill it. This is the HTML page. It says food dispenser control station. It has two options: give food to your pet or do not give food to your pet. Give food to your pet will set the food dispenser represented by LED for 5 seconds, and do not will turn off the dispenser, which is represented by continuous blinking of the LED here. This is ThinkSpeak. Whenever the owner gives food to the pet, it will be represented here. As you can see, 1, 2, and third meal given here. The notification will pop up on all the devices which has your push bullet ID. Basically, I am showing you the push bullet notifications on my laptop. It says June 4, 2020 at 10:10. Dog bowl is already full. No need to refill. While the other one is motion detected and it sends me HTML link which will I open and then I can access the HTML page. Thank you for watching my video.